methods for multiplication. In order to achieve that, we're going to do these 3 steps on our success criteria. Firstly, we're going to expand our use of mental multiplication methods. So we've worked on mental multiplication throughout the year, and we're going to build on that in this lesson. Next, I can use bar models to round and adjust. We've done a little bit of this with bar models, mainly with problem solving, but not too much. And I can use the formal written method for multiplication to check my answer. What do I mean by the formal written method for multiplication, Peggy?
So it'll be like a 27, it'll be like the number and then like times like a single digit number or like a more than 1 digit number.
Excellent, and you've encountered something really important there as well. So we have our column method, or our chimney sum sometimes we call them. And we sometimes can do like 2 digits by 1 digit, sometimes 3 digits by 1 digit, but we can have that bottom number be a 2-digit number as well. And that's going to be important for our lesson too. Okay, starting yourself off please. This is a partner task. So please do it with the person sat next to you or with a 3. Can you please start by reading these 4 questions and answering them? I'm going to give you a couple of minutes and then I'm going to come round and start looking for answers. This is going to be, when I answer them, a no hands up situation. So you need to make sure you and your partner have a good idea, or at least a question about the question if you're not too sure. Any questions before we get going? Awesome, let's get started. 4, 3, 2, 1. Pencils down for me, please. Excellent, thank you. Just got a couple more pencils to put down. There we go. Excellent work, thank you so much. Okay, as I'm coming around the room, I'm seeing a problem with the first one, and it's absolutely fine. What lots of you are doing is going, I can do that sum. I can do 392 times 48. So I'm just going to do, I'm going to pop it into a formal written method, and I'm going to do it. What's the question actually asking you to do, though? Yeah, Logie.
To round the 2 numbers and then make it like estimate what your answer should be around.
Yeah, so to round the numbers to make an estimate that we could do in our head. So, anyone got any ideas for this one? What might I round these numbers to? You?
450.
So if I round these numbers to 400, there we go. If I round these numbers to 400 times 50, then does that become a sum I can do in my head?
Yeah.
How could I do that one in my head? What mental method could I use for that one? Taha?
What I did was I did 5 times 4, which is 20, and then you add the 3 zeros.
Well, we're not really adding the 3 zeros, are we? What are we doing?
We're moving to the next column.
Yeah, so we need to move 3 place value to the left and then put the place value holders in. But yeah, that shortcut is fine. So we would have 20, and of course we would be timesing it by multiplying it by 1,000 because we need to move those 3 place value columns. Does that make more sense for that first question? Okay, awesome. Let's go on to question 2, 3 and 4 then please in your pairs. Carry on, off you go. 5, 4. Pencils down, please. 2. Excellent, thank you that table, thank you that table. 2. 1, just waiting for a couple at the back. And 0, thank you very much. Okay, someone talk to me then. Factor pairs. What are factor pairs? Let's start there. What are factor pairs? Jessica?
It's like when you times 2 numbers to get 28.
Yeah, 2 numbers which we multiply together to get the product of 28. So, what are we going to start with? What are we going to start with? Nilesh?
You could do 4 times 7.
Okay, that's not where I would have started. Why might I have started somewhere else? You are correct. But where might I have started? What's a more kind of systematic, logical place to start?
You could like start at maybe like well we could have just done like half of the number times 2.
Okay, again, you are correct. So you are correct. So we can do the forming. There is a 2. 2 is a factor, 4 is a factor. But Finley, where might I have started? Where's a sensible place to start when listing factor pairs?
I think you could start at 1 times 28.
Yeah, absolutely.
Every time you half the number that's like, so you double one number and half the other.
Okay, so, yeah, good point. So we can do that. We need to check. We need to start with 1. Every number has at least 2 factors, doesn't it? 1 and itself, other than 1, which is 1, right? And other than, even prime numbers have these 2 factors. So we had 1 and 28. So now I've checked that it's 1 is a factor. What's the next most sensible place to go? What number am I going to check next if it's a factor? Georgina? 2. Is 2 a factor of 28? Yeah, what do we call numbers where 2 is one of their factors? Numbers that are multiples of 2, what do we call those numbers? Brady? Or even numbers, yeah, absolutely, good stuff. So what is the factor pair of 2? 2 and what, Georgina? Finish it up. 2 and 14, excellent. What do I need to check next? Louis, what do I need to check next? I've done 1, I've done 2. Yeah, I'm going to check 3. Is 3 a factor of 28? No, it isn't, because it's not, 28 is not in the 3 times table, so I know 3 is not right. What do I need to check next? Ellie, sorry.
4.
4, is 4 1?
Yeah.
Yeah, and what is its factor pair?
7.
Awesome, that was the one that Nelis told us at the beginning, wasn't it? So we knew that one was coming up anyway. What do I now need to check? Peggy?
5 and then 6, then 7.
So 5 and then 6.
Yeah.
Are they even factors? No, they're not. And then 7 I've already got there, haven't I? So I've used up all of my factor pairs. Those are my 3 factor pairs. Well done, we were getting that as I was walking around the room. Okay, next one. I'm going to ask Avin, how would you solve expression of 14 multiplied by 6?
I would times 6 by 10, which is 60,
Mm-hmm.
and 6 times 4, which is 24, and then add 1, which is 84.
Who likes Avin's method for doing that? Who would use Avin's method for doing that too? Anyone would use a different method? Jacob, what would you do?
We start at 12 times 6, what is
So you start with 12 times 6 using a times table knowledge. So 12 times 6.
2, and add 2 6 is what
60, it's 84. That's a really good answer. Okay, next one. Rory, how can I solve the last question, question 4, 140 times 60?
So you saw how that last one was 14 times 6. All it is adding double 0. So it's basically 14 times 6 again, which is 84. And then you see the 2 zeros, so you add those at the end.
Okay, again, we'll repeat it. Am I just adding 2 zeros?
Yeah.
Am I adding 2 zeros? If you add 0 to something, the number stays the same. What am I actually doing? I'm just going to ask Rory, what am I actually doing?
So you're timing 140 times 60.
Mm-hmm.
So then you remember to keep the zeros at the side. So then you do 14 times 6, which is 84. Then you slide the zeros back on.
But am I just sliding zeros on? We spoke about this a second ago. Listen up for this, Rory, because we did talk about this. Caitlin, what are we actually doing?
No, you're actually just moving it to place values.
Yeah, we're making it 100 times greater, aren't we? Because this is 10 times greater and that's 10 times greater. So together they're 100 times greater. So we need to make the number 100 times greater. Awesome, good work. The pencil's down for me there. As we move on to our main part of our lesson, our new learning for today, we are going to be looking at this sum first. Tiny, there he is, the turtle, is working out 423 times 21. So, this is what Tiny tells us. He says, I can, pencils down there please, pencils down. I can partition 21 into 20 and 1. So 423, using a bar model, can be split into 20 and 1. Then, I can do both of those sections in my head. 423 times 20, how do I do that one mentally? Jamie?
Times 10 and then times 2.
Yeah, awesome. You could do times, multiply it by 10 to get 4,230 and then double it, or you could double it first to get 846 and then multiply that by 10, 8,460. So this is a way, we'll be using the written method and the bar model today, but this is a way to help us in the future be able to scaffold it so we can do it mentally. Then, what have I got to do next? What's Tiny going to do next? Anna.
He's going to add the 1.
He's going to. So does he just add 1?
No, he's going to add the 5.
times it by 1, and then he's got 20 times 423, 1 multiplied by 423. So then what's the final step? What does the tiny need to do at the end? Rory?
Add them together.
Add them together, which would give an answer. How would we add them together? What method might you use to add them together, Ewan?
You could add the hundreds, then add tens and add the ones.
Yeah, this one has no regrouping or exchanging, so we might be able to do this one mentally. How else might you do it just to be double, triple sure? Yeah.
A column method or a number
You might use a column method or a number like this. So all those methods that we've got together. So, I want us now to use this method to calculate one of these. I'm just going to do one of them, and we're going to start with 301 times 36. Where do I need to start? Which number am I going to partition, do you think? Have a chat with the person next to you. Which number is the one to partition? Okay, which is the number which I'm going to partition then? Who can help me out? Mila, what do you think?
36.
Why the 36?
That's the number you're changing 301 by.
But we know that with multiplication we can, the inverse is always true as well, so it doesn't matter which way round in the sum they are. So we could do it times 30 and times 6. 301 times 30 and then 301 times 6. I think there might be an easier way to do it. What might be an easier way to do it?
If you just partition 301 into 300 and then 1.
Let's have a look then. So if I do it this way, I need to do 36 times 300. And how do I do 36 times 300 in my head? What do I need to do? Yeah.
Triple 36.
Can you do that for me?
It's 100 and 108.
Okay, excellent. I like the way you worked out as well. You did 36. So you did 30 times 3 is 90, 6 times 3, 80. Adding them together, 108. And then what do I need to do, Loki, to finish that off?
Then you move it to place values.
Okay, sorry about that technical glitch. So, as Atom told us, we had to add the two numbers together. We can do that in our heads. We can do that using a mental method. So, here is what I'm going to ask you to do. Just check your learning now. Here is a new calculation for you. 78 multiplied by 9. What bar method, round and adjust method, might you use to calculate this? What might you round to? What might you need to adjust to? Advait.
9 times 70 and then 9 times 8.
So you could do 9 times 70 and 9 times 8. You could partition. Is there anything else that you might be able to do? Arif?
80 times 10.
You might do 80 times 10 to get a mental estimate first. That's a good one. What about using the bar model like we had a second ago? What might I do? Rory?
You add 78 9 times from 0. From 0. And 9 times.
You're just going to add 78, add 78, add 78, add 78. Repeated addition. Is that the most efficient method to use?
No.
Probably not. What could I do in my head that's close to 78 times 9? Ewan?
5 and 4.
78 times 5 and 78 times 4?
Yeah.
Okay, is there anything that's even simpler than that then? Jacob?
Take away the 8, so 70 and times 70 by 9.
So, what, okay, okay, hands down. I'm just going to explain to you how I would do this one. Instead of doing 78 times 9, I could do 78 times 10. See, some of you said it, we went there, 78 times 10. And then, what would I need to do? Okay then, take away 1. So, if I've got 78 times 10, what is 78 times 10? Advait? 780. And then what's 78 times 1? Yeah? 78. And then what do I need to do? Advait?
Add them together.
That would give me 78 times 11.
And subtract.
subtract, so 780, subtract 78.
Which equals 702.
Okay, good work. Right, we've done that one. Using the same method then, that round and adjust, I would need to work out what is 56 times 9. Using that same method with your partner, please. Off you go. Okay then, 5, 4, pencils down for me, 3, 2, 1, and 0. I've not spoken to yet much in this lesson. I've asked Murray. Murray, how am I going to work this one out using a bar model? Round and adjust.
So you round the 9 to 10,
Yep.
and then you put a 1 as well. So at the end you minus that number.
So 56 times 10, yeah, absolutely is 560. And then I want to take off
56.
56. And what would that give me?
504.
Excellent work. I can see some of us on this table, especially, and over here, we had that answer as we were going round as well. How might I, well, it says here, and when we get to our worksheet in a second, you could then check your answer using the formal written method. 556 multiplied by 9, check the answer. And I know you know how to do that because we've been doing it in previous lessons. Okay, talk task time. I would like you to use the method that we just discussed to work out this one. So firstly, which number is the number that you think you want to round? Just be thinking in your head. I'll come round and talk to people individually. Which number is the one you want to round? And then how much do you need to adjust? Have a look at it. 63 multiplied by 99. If you get that done, then check your answer using a formal written method. Make sense? Okay, off you go. 4. So pens, pencils down for me, please. Okay, so I have 63 multiplied by 99. Finley, start me off. How am I going to start this question?
So, you will start by doing, well, you'll round up 99 to 100.
Okay, stop there. Who agrees with Finley that 99 is the number that we should round? Good, that's most of you. Just before we'll continue with Finley. Why is 99 the number that we should round? Jessica?
Because it's close to 100, so you can just do times 100 and then just times it by 1 and take that away.
Yeah, because then we only have to adjust the 1. So we can do 63 times 100. We can do that one mentally using our place value method. And then we can just take off 63 times 1. And that would give us 63 times 99. So Finley, sorry, carry on. Where were we? 63 multiplied by 100.
So then you move it 2 place values, which would get you to 63,000.
Is it 63,000?
6,300.
Yeah, or how might I say that?
6,300.
6,300. Excellent. Carry on.
And then what you do is you take away 63
Yeah. Why am I taking away 63?
because the actual sum is times by 99.
Awesome. So now I'm doing 6,300. I'm going to get Finley's brain break. 6,300 subtract 63, which will give me the answer. Peggy?
6,237.
Awesome. How could you work out that last bit? Who would do that mentally? Who would be doing that mentally? How else might you do that subtraction sum, Taha?
Chimney sum.
You might do a formal method of chimney sum. Now, I'm going to ask you all to work it out using the formal written method, and we'll talk about them afterwards. Off you go. 2, 1, and 0. Okay. Who is going to talk me through this? We've done long method for multiplication. I've asked Julia to start me off. How do I start off?
3 times 9, which is 27. And then since both the numbers, and then you do 3 times 9, yeah, which and then you do 6 times 9.
Yeah, absolutely. So I'm starting with my ones. Good. Well corrected yourself. 9 multiplied by 6 is?
54.
And then,
Add 2.
which gives me?
56.
Excellent. Well worked out. Who can remind me? We've talked about this a lot. What is that all-important next step, Lovey?
Place value holder.
Yeah, because I'm not doing 63 times 9. I'm actually doing 63 times 90, aren't I? So I put that place value holder in there, and then carry on for me. Yeah.
Well, you're counting it when it's same numbers, so the answer should be the same.
So the answer should be the same. Can we do it anyway, just to check?
Yeah.
So 9 multiplied by 3 is?
Times
27. 9 multiplied by 6 is?
It's 54.
54. Excellent. And then add the 2 would give me 6. Good stuff. So it was the same. So well done for using your efficient method to find that out. Then what do I need to do? What's the final step that I need to do, Jamie?
You add them together.
Okay, awesome. So all together as a class, please. 7 add 0 is?
7.
Good. 6 add 3 is?
13.
Good. What do I do, Murray, when I'm writing 13? One over there we go. 5 add 6 add 1 is?
12.
12. Good. 2 and carry the 1. 5 add 1 is?
6.
6. Good. Did I get the same answer both times?
Yes.
Good. Which method would you prefer to do? Who thinks that the round and adjust method is the easiest method to do? Who thinks that this method, I already know this method, is easy to do? So when we have our close numbers, this could be easier. The benefit of this method too is that we can do lots of these parts in our head. We can do lots of these parts mentally by just using our times tables and place value knowledge. This one, a little bit more time consuming, but that's why it's good to do both to check. Okay, can you please try for me questions 1 to 3 on your worksheet? I'm going to give you 10 minutes, and then I'm going to start coming round with some answers. Off you go.